So there's one more fact about gravitation that we'll talk about right now. And again, I can't spell gravitation. I can't spell when I'm writing on a big board for some reason. Now, again, Kepler didn't know Newton's law. He just knew the laws of planetary motion. Newton came up with a more general law. And then finally Einstein comes along and makes an even more general law about what actually causes gravitation, which has to do with the bending of space and time. We'll talk about that later, not today. But there's more, so Newton's law isn't the most fundamental gravitational law. There's more to the picture, and it has to do with the nature of time and the fact that space is not simply laid out on a Cartesian grid of x and y axes, but that in reality these things kind of curve a little bit and life gets really interesting. That's what Einstein is about, but he's more towards an actual explanation of why gravity happens, whereas Newton is simply coming up with a form of the equation that works enough to get people to the moon, but it's not perfect. Now, there's one more thing about gravity using Newton's laws that we want to talk about, which is if you've got an object orbiting around another object. So we've talked about, here's the sun, and then here's the Earth, and it's in orbit around the sun. But what if you had, and these things exist, there are things called binary stars, and binary in this case it makes it two, bi meaning two. You've got one star here and one star here, but rather than just falling into each other, they are rotating or orbiting, revolving around each other. And the center of that orbit is right in between the two stars, and they're roughly the same size. They're revolving around each other. Thea, you had a question?
They just spin. They don't move. There's no direction that they go to.
Yeah, they're just chasing each other around, and they might be going somewhere together, like to the movies or I don't know, something like that. But they're just spinning around each other. Now, I wonder if Dr. Charban could explain something about why this happens.
Я не знаю, он не знает, никто не знает. Кантор-шмантор.
So, Vladislav, could you interpret for us what Dr. Charban is saying?
Yes. But basically, it works like this. You draw the most extreme case of this example with binary star system in orbit around one another. However, in reality, all objects in orbit experience this relationship. For example, if you have let's do Earth-Moon system. You have Earth here, correct? And you have Moon in orbit around Earth, so to speak. We get to a point here where there's more to picture. The Moon in orbit here around Earth. However, the Earth is not fixed. It rather, like Moon, is also floating in space. And it is also attracted to Moon. And the two forces, again, are equal. The force of gravity on the Moon is equal to the force of gravity on the Earth, just in opposite direction, correct? They're pulling towards each other. So, the Moon in orbit around Earth, but also Earth ever so slightly in orbit around Moon. And how does this manifest itself? How do we see these phenomena? Well, it like this. The center of the Earth is there, but the Earth itself, this point hold on. the Earth itself wobble around little circle here. I'm trying to draw it correctly. Hold on. This point represents center of Earth. And this point, over the period of 1 month, wobble in small orbit, except because the mass of Moon is so small compared to the mass of Earth, the circle is inside the Earth. However, if Moon is larger, let's incrementally change the system and watch the change that happen. So the Moon is now bigger. Now you observe this. The Moon is in orbit, say that way. The Earth orbit around Moon is now a little bit bigger. Say something like that. And you keep changing system, making Moon bigger, more massive, and eventually you find that the two objects are indeed in orbit around one another. So the Earth orbit around Moon happens to be small circle inside Earth, whereas a Moon orbit around Earth is large circle outside Earth. It just simply appears that only Moon is in orbit around Earth, but really the two objects are in orbit around one another. And this is not very readily observed phenomenon, but it is true. Thank you, Dr. Charban. That was a very good explanation. It's remarkable how you can compress so much information in such a small statement.
Yes.
Thank you. Okay, any questions from the class? Not at this time. Okay, this. Okay, you can ask them.
Well,
Yeah.
It's back to that wobble inside the Earth. Is it elliptical? Is it round? Is it gyroscopic?
It's an elliptical, or it's an elliptical. They're all ellipses. But like I said, the orbits of the planets, the orbits of the Moon, are almost perfectly circular. They're only slightly elliptical, but it's enough to be observed, even in the day of Kepler. Now, we'll stop this lecture, and we're going to do one more introducing the next topic.